So this is a new tutorial series about NumPy. Uh, NumPy is a very essential tool for any data scientist, and there are like some 10-15 very important functions which we use around 90% of the time while solving our data science problems. So we are going to focus on the essential part of the NumPy because NumPy library is quite big and there is no point of knowing each and every function by heart. Okay, but there are like a set of functions, methods which are relevant, which are more relevant than others for your day-to-day data science workflow. We're going to look into them. Okay, so I am already assuming that you have installed NumPy. So just to make sure your installation is working properly, you can run this command, import NumPy as np, and then print the NumPy version. If this command is giving no error, it means your NumPy installation is proper. There is no issue with that. Now the first thing that we are going to do is we are going to see how to convert a Python list into a NumPy array. Okay, so that is very simple. You define any Python list and then just pass it to this method np.array, and you will be able to convert it into a NumPy array. Okay, then once it is converted into a NumPy array, you can implement all kinds of methods which are available in NumPy on this array. Okay, now the second thing is multidimensional NumPy array. So we all know in deep learning, in machine learning, we are going to use multiple dimensions arrays. Okay, like 2x3 array, 3x3 array. Okay, matrix multiplication is also a very important feature in the deep learning and machine learning space. So it is important to understand how to handle multidimensional NumPy array. Okay, so this is a Python list. It is a multidimensional list. It is a list of lists. So to convert it into NumPy array, it's just like we did before here. We will do the same thing here. Okay, you can convert it. Once you have converted the NumPy array, to get the shape and size and the data type of the NumPy arrays, you can use these attributes: shape, size, and dtype, as name suggests. Okay, what's the difference between shape and size? Okay, so you can see here the array is 2 rows and 3 columns, 1 2 3. Okay, so the shape will be 2 rows and 3 columns. Size will be number of elements in the array, so 6. Okay, and dtype will represent the data type which is available in the NumPy array. Next thing is some convenience function within NumPy. Let's say you want to generate some multidimensional placeholder matrix, placeholder array. Okay, this is very simple. If you want to create a NumPy array which has all the elements 0 but shape whatever you have defined here, like I have defined 3 rows 3 columns, so it will generate a 3x3 matrix. Okay, now it is 2 rows 3 columns. Okay, similarly if you want to fill all the elements with 1, you can do it like this. Now this is another convenience function. So let's say you want to generate a NumPy array which starts with 1, end at 6 with a step size of 1. This is the syntax for that, np.arrange. Okay, so let's take another example. Okay, so it starts with 1, end at 10. So this end at point is not including, it's excluding. Okay, and then the step size is 2. So we get 1 3 5 7 up to 9. If you make it 13, make it 10, it is 9. Okay, now if you make it 12, you see 11 has appeared here. Okay, now let's say you have a NumPy array and you want to convert it into a different shape. Okay, so the shape of A here is 6. Now you want to convert it into a 2 row and 3 column. So there is a method called reshape. When you run it, you will be able to convert a linear array into a multidimensional array, or right,